All right, good afternoon, everybody. My name is John Gerlai. This is the first in what will hopefully be a series of webinars on the common data formats that have been developed by NIST along with election officials and vendors. And today we're going to talk about the voter records interchange format and how it can help states that are looking to do all sorts of voter registration related retooling, whether it be online voter registration, VRI automation, automatic voter registration, you name it. So I thought we should give a little bit of history because some of you may have not been tuned into this work in the past, but it's been around for a while. In fact, it started in 2015. At that time, we were looking at what we could do to support NVRA and FPCA transactions. So the NVRA form is usable throughout the United States, and then the FPCA for military and overseas voters kind of sets a good baseline for voter registration transactions generally. But before too long, we realized that we needed to support online voter registration in an explicit way, and we renamed the format to Voter Records Interchange to reflect that. The initial version was adopted in Ohio back when I worked for the Secretary of State's office in Ohio in 2017, and is available through their online voter registration portal. Today, we've added several use cases to the format. The format is still in draft form. It has not been formally approved by NIST, though we'll go over that in a minute. It looks like it will be published at the end of this year or very early January of next year. So since 2015, we've added use cases to support things such as ballot requests, voter lookups, because a lot of these systems need to know if the voter is already registered in order to bring out the correct screens, or for automatic and automated voter registration, so the NVRA agency does not send duplicate voter registrations down unnecessarily. And a lot of this work came to be through prototyping a voter registration system in Virginia and seeing if the VRI format would work for the Commonwealth of Virginia. And we added these use cases in a very de minimis way without changing radically the format overall, so people who have used it in the past can continue using it, and it's kind of a easy upgrade. So what is the voter records interchange? Well, it's a common data format, and it's built based on a UML model. And if that doesn't mean much to you, that's okay. What it does mean is that the format is well specified in a formal way and has very good documentation around it. The format can be implemented as JSON or as XML, which are two popular formats on the internet. VRI is different from a lot of the other common data formats in that it has specific send and receive semantics, meaning that not only do we specify what gets sent from the third-party registrar, for example, to the online voter registration portal, but also what comes back. So we can note things like, did it get to the voter registration authority? Was the registration successful? If it failed, why did it fail? And also results from looking up an existing voter registration. The requests themselves consist of registrations, pretty obvious, ballot requests, including absentee ballot requests, permanent ballot requests for states that have that, and UACAVA FPCA type ballot requests. Like I said earlier, we support lookup requests for bringing back existing voter records based on a query. And I moved very quickly through those slides. So, Paul, if you could unmute yourself. Paul Stenbjorn has been helping develop a number of use cases related to the voter records interchange, and I'll let him introduce himself.
Hey, John, and hello, everybody. Thank you so much for joining us today on the first of this series of conference calls. I just wanted to underscore something that John said to begin with. Everybody is on mute, and if you do have questions at various intervals, we'll answer questions that are posted in the chat window. John, can you see my screen now? It should just be the VRI Use Cases screen. Yep, great. So in 2017, for those of you who don't know me on this call, I am the former Director of Election Services at Virginia Department of Elections, and I've worked in other offices as well, including the DC Board of Elections and Ethics, in various technical and administrative capacities. And so in 2017, I was asked to assist the VRI in identifying additional specific use cases that would be potentially benefit from the use of a common data model. The three specific use cases that I explored through historical data information, work with election colleagues, and actually going through some worked code examples are third-party online voter transactions, where a standardized format could be adopted by a state and third-party registrars to have an automated system for performing various voter registration transactions. This was actually one of the catalysts that led to the expansion of the VRI to consider voter lookup, where one of the functions that an external party or even an internal party may want to have on an online presentation of voter records would be a return of voter record status or voter registration, polling locations, or even potentially ballot information. There are other tools out there that do that as well. But the VRI is a fairly expansive format that can accommodate a number of different practices. And so the first use case that we explored was, and I'll dive deeper into these in a moment, was the third-party online voter transactions. Secondly, in the Commonwealth of Virginia, we have a process whereby we have electronic voter record interchange with our Department of Motor Vehicles. This was implemented in 2015, and there has been some of the challenges that we experienced in implementing electronic voter data exchange with our DMV had to do with our having completely different data sets and even different data definitions. So the use case discussed in the use case model that I worked on envisioned what a more streamlined common data model format of voter record exchange between NVRA agencies and election offices would entail. And then lastly, in DC and in other places, I have worked with vendor and homegrown developed electronic poll book systems, which are essentially just lists of voter records. And most commercially available electronic poll book systems require the transformation of voter data into a specified middle tier format for distribution to end units. Having a common data format by which that transit could take place would certainly expand the scope of potential solutions and also allow for easier updating of voter records in voter registration systems. This use case and the code examples that I modeled around it also envisioned something that in other work with other common data models seemed to really be a handy tool for election officials, which is a process by which a standardized denormalized data set, a flat file of voter data, can be simply transformed into a valid destination XML format. And I meant to click there. There we are. So first, third-party voter registration transactions. In Virginia, we worked for several while I was there, I've been gone for about a year and a half now, we worked with several external parties to attempt to integrate the Virginia online voter registration system with external parties. And at that juncture, what that mostly meant was asking the external parties to adopt to the format adopted by the state. In this use case exploration, what I did was I created a series of code examples, which I will show in a second, that envision what a state could have in its system, whereby it could accept a format, JSON request or an XML request for voter records, parse it, and then return valid data response. And again, that would dramatically simplify the process of implementing these systems. We also looked at some of the edge cases whereby, again, do we want to just do a voter lookup? As John mentioned earlier, the VRI was designed to be transactional. In the full narrative of this use case, we discuss the various potential levels of implementation, because mostly, as those of you who are in elections know on this call, ultimately voter registration dispensation is performed at the local level. And so a state will be essentially a vehicle to transmit a request for voter registration or an alteration to voter registration, and then submit that to a local authority who is ultimately responsible for the disposition. And so if you are so interested, the narrative of this use case explains where the VRI could be useful in each one of those specific use cases, sub-use cases. As I mentioned earlier, electronic implementation of NVRA, so that NVRA agencies are agencies that are required under the National Voter Registration Act to offer voter registration transaction services to their clients. They're mostly state agencies where there is a statutory responsibility for offering voter registration to its customers who have already provided information for other purposes. Most commonly, this is known as the motor voter law, because the Departments of Motor Vehicles are the primary agencies that are affected by NVRA. As I also mentioned, that in Virginia, and in other states have done this as well, have implemented an electronic transaction, record transaction interchange. The narrative of the technical process of implementing an NVRA solution between a state election agency and a state NVRA agency would be very similar to any other VRI transaction, where there is the potential for a voter record lookup to see the existing status of a voter, returning the existing voter registration address of the voter, and other attributes. Similarly, in many states, including Virginia, online voter registration relies upon the availability of driver's license information. So a VRI transaction could as well be used to be posted by the registration entity to the Department of Motor Vehicles to retrieve a signature and or a driver's license status. And again, the narrative goes through some of the real world challenges in implementing these solutions. And if we had more time, I would be happy to expand on what some of those have been historically. But just as a brief example, at least in Virginia, and I know in some other states, the requirement of voter records have a very distinct and very obvious reason why they have a requirement for a domicile address, an address that can be districted or can be geocoded. In driver's license world, it's much more important that the DMV has an address to which mail can be sent. So a greater weight is placed on mailing address than on domicile address. And this can create some challenges when trying to interchange address data. And lastly, the use case that was explored in narrative format and also in code was the electronic poll book data interchange. And as I mentioned in the opening remarks, electronic poll books can either be, again, in-house developed. The Commonwealth of Virginia actually had a long-term initiative to develop an in-house electronic poll book product. When I was in Washington, D.C., we also developed an in-house electronic poll book product for use in early voting, but but most of the electronic poll books that are deployed currently in elections in the U.S. are manufactured by a third party, and these third parties have a process by which state and local election officials export voter data that get re-imported through usually some middleware to a destination machine. And this transition, it can be fairly complicated, especially for smaller local election offices who have limited technical capacity. And then it also creates the potential for field mapping inconsistencies. The use of a standardized format can really mitigate a lot of those concerns and the data mapping anomalies. And this use case does explore, and I provide an example in code about how one would generate a recursive data set of voter records in a VRI format that could be consumed by a system. This is normally where in presentations I pause for questions and I look at our chat screen, and I do not see any, so I'm going to continue. We will share links with for certain items. This is the GitHub repository. And John, can you just signal me that you can see that?
I see it.
Great. We put together for some worked examples of code that can be used by others. And this is, I want to preface this by saying that the idea behind these code examples is that this is seed code. This isn't out-of-the-box code that could be used currently to run an application. But this would be a code that could certainly facilitate the development of solutions that would use the VRI. And also in here are more expansive discussions in the PDF files on the root of the use cases, the factors that were considered in the development and exploration of the use cases. Specifically, I'm going to dive into what the source code examples are. And there are 3 different sets of source code examples for those of you who are so inclined. There is a set of C# defined objects and some use cases, some developed use cases for VRI, for the use of the VRI. Most importantly, however, is the generated and slightly altered class library, which is probably going to be too big to show here, but I'll wait. And this is a series of class libraries that we built that model each one of the different elements within the VRI itself. And this allows for the development of additional C# calls, your function calls, and additional custom class objects that can inherit the C# code that will that can produce a valid VRI object. And it's terribly unexciting to show code, I know, scrolling by on a page. I will show you what some of the outputs from this example code can look like, and they're very simple examples. But these generated XML examples were generated using the sample code that is in this repository as well, and this essentially will show what a potential output to an NVRA agency would look like, and then also what a response from that NVRA agency might look like as well, or response to that NVRA agency. So this would be the principal part of an NVRA transaction, where NVRA agency sent the initial file, it was parsed, and the voter lookup was conducted, and a valid voter record was returned with additional information like the existing voter registration number. Secondarily, there is also a source code repository where, very similarly to what we built in C#, we also developed in Python. The Python class objects, again, define all the respective objects in the VRI. And again, this is too big to view, so I'll have to show it here. But in essence, once you become a little bit more familiar with what the VRI looks like in XML format, the class objects within this library will seem very, very direct. and I also created a worked example here about how an external call could be made to this VRI class library to look up a voter. So the way this is structured for example purposes is I have a sample JSON data call that is formatted to be run through the VRI model and return a valid VRI JSON response. And for show purposes, I can actually run this. And what this will do is, again, this is a stubbed out example where it'll actually ingest that JSON sample data, put it through the class object library, look up in a fictitious database to find this voter record, and then return that in a valid JSON format in the VRI. As I mentioned earlier, these code examples are seed code. I am happy to assist any one of you who are developers in using it. The class object libraries are reusable out of the box. The sample code is obviously for example purposes, and you may use it as you choose fit. I look forward to continuing to explore what the potential, oh, I'm sorry, I meant to show one additional example. I am sorry. The last is the final library is actually a library that I created for use within SQL Server itself, and it does create there's a SQL script out here to create a schema object in SQL. It allows for validation of XML data stored in SQL Server. There are some vagaries about using SQL Server with certain complex XML XSDs, and so this has a bit of a customized XSD that it has to ingest, and in fact the customized XSD is in this repository as well. But ultimately the objects are the same in SQL. It's just the way it has to do its validation. It can't use the official XML as it lives in the GitHub repository. And lastly, the last example I wanted to just briefly discuss is something that we had talked about earlier, which is the customizing of the ingestion of a reference flat file. And so I have a reference flat file with fictitious voter data in the repository, and there are code examples within the CSV conversion CS file, which will take that data and will use the object library also in this repository directory to generate a valid output in a VRI format. And again, this uses the recursive feature of the VRI to be able to provide a voter records response for multiple voter records, each inheriting all the attributes of a valid VRI record. And I note that John has posted a link to the repository in the chat room, and we will have my contact information and John's contact information at the end of this presentation. So without further ado, and seeing no additional questions posted in the chat window, John, I think I'm going to turn this back over to you.
All right. Thanks, Paul.
Welcome. I'm going on mute again.
So a question that often comes up with common data formats, and I've been working on them since 2012, is making sure that they handle all the edge cases, and elections are full of edge cases. The good news is the format can accommodate state-specific needs around storing things that we didn't think of, either didn't anticipate or felt couldn't really translate across multiple states. So all these classes you see here, voter assertions, contact methods, identifiers, geography types, form types, those can all be extended with a custom value. For example, if contact method right now I think has like phone, email, fax, etc., the standard. If you wanted to say what's their ICQ number, that would be another type. I don't know if people still use ICQ, but if you wanted to store that, that would be a valid use of the state-specific requirements extension. Additionally, we support extensibility through named value pairs. An example of that would be if you wanted to collect additional data points. In Ohio, we needed to collect the language that the voter used to fill out the voter registration form, so we knew what information to send them, what language to send additional information to them in. And you can think of other use cases for that. We do caution against doing that unnecessarily, only because those custom values are only known to you and your consumers, and we hope you do make it known to your consumers in good documentation. Otherwise, the format will be less and less interoperable in your jurisdictions. So we didn't go over the schemas too much here. They're available on the GitHub repository, and I'm going to send a link to those repositories so you can take a look at them. But there are some things that cannot be specified through a schema language. Schema languages ensure that things are in a proper structure, in a proper order, that things are named correctly, but they don't keep you from spitting out nonsense. So an analogy in English would be a sentence that doesn't follow the subject-verb-object order. And I have an example at the top, hungry I am, doesn't make a lot of sense, but I am hungry because we follow SVO order, makes a little bit more sense. So here's an example of something that would be not validatable by a schema language. So I am a tomato is following subject, verb, object, but it does not make a whole lot of sense. And there are examples of that in the real world with the voter registration interchange format, voter records interchange format, such as specifying that one of the values is of type other without specifying the other type, or a really good example would be the date of birth for someone. Someone saying in their voter classification that they will be 18 by election day, but their date of birth indicates that that's impossible. There is a language that fills in the gap. It's called Object Constraint Language, and we've built a number of business rules that will solve those problems and check that the format's not only used in a consistent way structurally, but semantically as well, and that's going to be the demo I show you. So real quick, we have the specification up on GitHub. It's under the NIST GitHub repository, Voter Records Interchange. And actually, I'll put that in the chat window in case anybody wants to take a look who hasn't seen it before. In the chat window, we have UML documentation here that goes through all the numerous classes and enumerations and documentation regarding those values. It's quite long. I certainly couldn't get through this in a 1-hour-long webinar, but it is available for you to take a look at. What's been added to the specification are the business rules, and these are the things that we can validate with the object constraint language. So, for example, the additional info class, which I spoke about earlier, allows you to associate name-value pairs, whatever arbitrary data you want to pass along. And there's two types of data that you can send down, either a string value, which is textual information like the voter's language, but could also be what we call a file value, some sort of binary object, such as an image, maybe a scan of a driver's license, etc. And either of those can be provided, but you shouldn't provide both at the same time. So we have a business rule here that says the file value or the string value should be defined, but not both. And we have other examples of business rules, such as ballot request has a start and end date if it's a temporal ballot request. And obviously, the start date needs to come before the end date. Things of that nature. So this is going to get a little in the weeds. These examples were developed using the Node framework, which is a way to create applications in JavaScript that run outside the browser. And it's free for download. I recommend you download it if you want to try out these prototypes. And I've published to the Node Package Manager, which is a popular way to get source code in Node, something I'm calling SemVal, or the Semantic Validator. And there's copious documentation here. I'm not going to get through all that. But it's available online. You can download it. You can install it with just one line on your command prompt, PowerShell or Bash or whatever. And it will allow you to validate JSON instances to ensure that they're compliant with these business rules. It has a command line interface. And let's see if I can bring up an example here. So very much command line interface. It lists out what it's capable of doing. And I have a JSON instance that we're going to use as a demo. And it's got a couple things wrong with it. So let's just run the validator and see what it says. All right, so it gave us two errors, and the errors are in JSON, which makes them pretty easy to parse out. One is that the ballot request is required, failed, and then this VI must choose one failed. And if we look at our rule set, VI choose must choose one is that rule we looked at earlier, where the file value or string value must be defined but not both. In this case, it's neither. So neither the string value or the file value were provided. And in this case, we're saying that this voter has a Social Security number but not providing it. So let's fix that. That's a string value. Save that and rerun our validation. And we see that error went away. The only remaining error is this ballot request required, which just says that when you have a ballot request, you must provide a ballot request object, which ballot request is one of the four kinds of requests you can make. You can make a registration request, a ballot request, a lookup request, and then a other request. And you can compose registration and ballot request together, for example, in the case of an FPCA form. So if you say that you're sending down a ballot request, you need to specify details about a ballot request, which if we look at the UML models here, include things like the mail forwarding address, the start and end date we looked at, if you're in a state that only allows one-off type ballot requests, the election that is being requested, etc. So we're going to fix that by copying and pasting in some code here, right here. And here's our ballot request. There's not much in there, as you can see. but it will be enough to make that error message go away, and now it says it passed. You can add your own state-specific OCL rules, and we state how to do that on the NPM page here. So creating your own rule sets. I don't know why it's not scrolling down. Shows you the format they need to be in. Any compliant OCL rules will work, and in prototyping with Virginia, we did just that. There were certain rules that applied and made sense to the state of Virginia, and we created additional rules to validate those types of constraints. And this could be used in your own systems. All this code is open source and available to you, just like Paul's is. So I'm going to go back to the PowerPoint. So another thing that often comes up is, which format do I use? We have the UML model, which is, for all intents and purposes, a picture and can't really implement the UML model directly. So we provide two formats that you can implement, JavaScript object notation and XML. The big difference between the two is how easy they are to use in certain environments. So JSON is extremely low friction on the web. So anything that you're doing, on the client side or in a web browser, you're going to lean towards JSON. Has very good open source support with all the modern languages, Python, Node, which I just showed you. So that kind of begs the question: where does XML fit in? Does it matter anymore? I think it still does. XML has very good support by all the enterprise vendors, your Microsofts, your Oracles of the world. It's also a bit more extensible. I guess it lives up to the X in its name. And you're going to be able to customize it more to meet your needs. You're going to be able to validate it more easily if you do have one of those heavyweight type stacks like .NET or Java. So in that case, I think it's more suited to system-to-system type interactions, such as an NVRA agency to voter registration authority. The good news is you don't have to pick one. You're not pigeonholed into JSON or XML. They are one-to-one. They all implement the UML model 100%. So anything you can do in one, you can do in the other, and it's very easy to convert from one to the other. So pick what works for you. Like I said, the CDF is near completion. It is in NIST internal review. We're hoping to have it out either by the end of this year or the very beginning of next year, January, in fact. The review draft is available on GitHub, and we'd be, happy to get your comments. Though hopefully they won't be, any major changes at this point. With that, that's the end of the slide deck, and we ended a little early, so I'm going to take us out of event mode and open this up to questions, so people will be able to unmute their phones at this time and ask any questions they might have directly. I can't unmute you on my side, so if you want to speak, you're going to have to hit the unmute button on the interface or dial the number. What was the number, Paul? Star something? Star 7. If you're called in, you can dial star 7 to unmute yourself. I do see that Ryan Macias asked the question: is the PowerPoint presentation going to be made available? And John? Yeah, I'll send it out to all the attendees. Well, actually, anybody who signed up to the webinar will get a copy of the presentation.
And
Hi, this is John Sebas. I do have a question. If now is the right time for them.
Yeah.
Okay, and thanks, John and Paul. It's wonderful. Really, really wonderful what you're doing. My question is about potential adoption for the use case of online voter registration system exchange with third parties. So right now, we in Rock the Vote are running some systems that interact with Virginia and Pennsylvania to send voter registration requests in a sort of state-specific one-off data format. I'm wondering if either of y'all are aware of any other states that are considering opening their OVR systems to third-party submissions and might actually be interested in using this format, because I can tell you the homegrown formats have all sorts of really horrific semantic issues and cause reliability stuff that's costs a lot of money actually to recover from. So I'm a big fan of this format, and I'm wondering if it might actually be used for that use case in the real world anytime soon, if y'all know about that.
John, do you want to kick off your response to that?
You want to put me on the spot, huh?
No, not at all.
No. I'll kick off, John. But realistically, I do not. I am not personally working with any state to adopt VRI. I know there's a lot of positive discussion around it. But I'll let John July speak more specifically.
So I can't say anything specific in regards to particular states that may be looking at this, other than several states are looking at this format.
Good.
I mean, it's been the intention all along to get states off these one-offs, both to ease development for the states, but also for the third parties who have to build a number of one-off interfaces. So I think over time we'll see more and more adoption of this format. And I believe Jen Tolentino is either on the call or was on the call at one point in time, so she's very aware of this format.
Oh, of course, I know she is, because actually in our collaboration with Rock the Vote, I mean, we use a JSON binding of an earlier version of the VRI standard for data interchange between an OVR client, a native mobile app, and our back-end system that submits it to Pennsylvania and Virginia. The odd bit is, of course, we have to translate from the common data format to the state-specific data format. And the issue about cost that I wanted to bring up, and this is maybe just an awareness issue, so anybody who's talking to states about this, is it actually costs a significant amount of time and money on the state side to develop a one-off format. It evolves over time. There's versioning problems. There's semantic issues. So adopting a common data format is really sensible, because real experts in data modeling and transaction modeling have done a lot of hard work to make the format really solid. So you're not debugging the format on a production system. And that, of course, obviously helps client organizations as well. So that's why I'm such a big fan of this. And I wasn't trying to put you on the spot. I'm just trying to say it's good to know that there are several states aware of this. That's really all I was asking.
And John Sebas and July, this is Ryan Macias. I will probably speak out of turn, but I am pushing internally for our agency, for the EAC, to either try to do a webinar or to bring this forward and share this with all of the states, because we know that there are states that are using the $380 million that was distributed from us for updating their voter registration systems. And for bringing forward technology. And so I have not got a definitive yes on this, but I will tell you that there are members of our agency that are very interested in this and making this as publicly known and available as possible, and doing whatever we can to make sure that the states are aware of it as well.
Okay, well, let me suggest one thing about that. As we know, for just adoption of OVR generally, one of the things that really helped with OVR to the 30, however many states that are doing it, is use cases that demonstrated that it actually saves money by eliminating paper processing of voter registration requests. It may be that some folks at states like Pennsylvania, Virginia, maybe Rhode Island, actually can privately share with y'all, if you're doing this outreach, what were some of the costs that they incurred in doing their own data formats and versioning and changes over time, whether it's for a public-facing system like the one that the Rock to Vote Trust Vote system uses, or just internal interchange with DMV and stuff. Because I think that this format actually might be better adopted if people understood that it's going to save them time, money, and effort, and increase reliability as well. So just my opinion.
So, Ryan, you'll be the first one to get the PowerPoint, and I will also say this meeting is being recorded, and we plan to distribute the webinar in some manner on the internet where people can get to it and watch it on their own time. Paul, did you see Philip's question? Would you be able to touch on that?
Sure. There are a lot of many of the same design principles, and even some of the objects were used to build the VIP schema 5.1 were inherited by the VRI. The VRI is not intended to be a subset of VIP data, but there's similar nomenclature and there are similar elements between the two different models. And for example, like the definition of geopolitical units and how they're related within the VRI is very similar to the way that was envisioned in the VIP 5.1 schema. Go ahead.
I was going to say, are there different use cases or different reasons why someone would be using VIP versus VRI, or
yes.
Would both? Okay.
Yeah. So the principal difference, from a conceptual difference, the conceptual difference between the VIP schema and the VRI schema is the VRI is a voter record schema that defines a specific individual voter records. The VIP format was always intended to be to represent publicly available data and not provide access down to the individual voter record. However, VRI and then VIP share a lot of the ancillary data, the geospatial data, the relational data between polling locations and election districts, and even down to like the election definition level, where there are either shared objects or very commonalities between the objects. Does that answer the question?
Yeah, that was a perfect answer. Thanks.
Great.
Yeah, and I would say that we've worked very hard with the VIP team to make sure that when we define classes of things that we're defining them in a similar manner. In fact, a great amount of the revised VIP standard came from the election results reporting common data format. So there's been a lot of cross-pollination between VIP and the CDFs.
Yep.
Any other questions? And they don't necessarily have to be about what we presented, though they should be about voter registration interchange.
Is this standard going to be published relatively soon? Any idea? Is it sort of in the phase where trying to button it up, not take on any new issues, get it published, sort of thing?
It's we're looking at January. And John Wack, do you want to maybe chime in on that? You're going to have to unmute yourself. Well, anyway, January is the date that I've heard. It's currently in internal review at NIST. All the latest documentation is available on the Github Repository. We're expecting no technical changes whatsoever, though the body of the document may be wordsmithed a little bit. The narrative document may be wordsmithed a little bit. So I certainly wouldn't be afraid to use it as is. Wait for that stamp of approval from NIST. Ohio's used it. Virginia's, seriously looking at it. So states are using this format and have been very successful in using the format.
Hey, John. I've managed to finally unmute myself. And the only thing I'll add is that there is some plain language expert people taking a look at the document right now, but it's really more, well, I would anticipate changes more in the introductory material and, some of the documentation describing classes and attributes, but nothing that would change the structure. And I think we're still on track for January. I have been avoiding the newspaper for quite a while, but recently I learned that there may indeed be a government shutdown. If that happens, I'm sure that would delay things a bit, but hopefully not.
It would be a week from Friday, I believe, John. Is that correct? Yeah,
well,
but who's counting? So there are two questions we've gotten posed, and John Wack, if you wouldn't mind helping answer one of these. Ray Lutz asked, that he would like to hear about the larger picture about how the various standards work together. Do you want to speak a little bit about the broader work on standards at NIST and where this fits into the overall standards work?
That's a complicated that's a good question, but the answer is somewhat complicated. There are 4 common data format specifications, and then there's an additional one on the glossary that will be out a little bit later as the requirements on the new VVSG are finalized. The 3 of them, VRI, election results reporting, and cast vote records, share a number of similarities, and there's been an effort to, if I'm not wrong, I believe that the same schema that's being used for election results reporting version 2 is being used by VIP 5.2. So there's been an effort to keep things more uniform, but I do think that once these specifications are complete, the real work is ahead, and that is to make it more understandable and accessible to people who might want to implement it, and provide, like John Sevis was talking a little bit about, whether having some information about how much money might be saved by implementing some of these, that sort of information needs to be brought out. So that's not a great answer, but I think they largely do tie together, but making that easier to understand is next year's work.
Great.
So there was a question about the addressing data inside the format, and I would say that we're using a standard called, and it's a mouthful, I actually know the number better than I know the proper name. Oh, and I click on it, it says URL cannot be found. The United States Thoroughfare Landmark and Postal ...
Which is administered by the Federal Geographic Data Committee, the FGDC, which is the federal government, and that is the addressing standard that the VRI inherits.
Yeah, so I don't know anything about the National Address Database. Well, I shouldn't say I don't know anything. I haven't looked at it recently, but the FGDC standard was supposed to unify how the post office, census, and a number of stakeholders did addressing. And it remains to be seen if the format will actually get used across all those federal stakeholders, but anticipation of them using this format and the fact that it's so well vetted and well documented, we decided to adopt it as our format instead of reinventing the wheel.
It looks like they are interoperable. I'm looking at the, so they're using the, what's it called, the NINA U.S. Location Data Exchange Format, CLDXF standard, which looks like it also built on top of the STD 016-2011 FGDC standard.
Yeah.
I was actually a little bit, I was thinking maybe potentially a little bit less around the alignment of the standards, and maybe if there's opportunities to do more, long-term thinking, maybe something more sophisticated like the National Address Database. I think we'll have unique identifiers for addresses and kind of serve as a canonical address database for addresses in the United States. So I don't know if there may be an opportunity to tie in that as a kind of canonical data set.
So I don't know if she's still on the call, but Jamie Chesser from NISJIG.
She is commenting about this. So, Jamie, if you can unmute, if you'd like to add your thoughts to this.
Hi, everybody. Yeah, I just put a few things in the chat, and I'd be happy. I don't have them at my fingertips right now, but NISJIC has a addresses and transportation committee that works specifically on the NAD. We have, over the years, put together a map showing what states are involved in the National Address Database, supplying data for it. I'd be happy to share that with this group, and also put you all in touch with some of the folks on that committee that could provide even more information.
Great. Thank you so much, Jane.
Sure.
So we're right at 5 o'clock Eastern. Any rapid fire questions before we go? Well, thank you so much for your time. I know there's probably a million other things you could be doing at 5 o'clock on a Friday night, and I really appreciate your time. We will be sending out a set of links to resources, a copy of this PowerPoint, and Paul and I's contact information. Thanks so much for joining us. We'll be in touch. Take care.
Great. Thanks, everybody.
Thanks, John and Paul.
Thank you.
Bye-bye.
Thanks, everyone.
Bye.